Hi everyone. In our previous lecture, we saw about strategy design pattern, what it is, and um how we designed our code base. So, it's just an implementation of it for you to look at. So, Duck, this is an abstract class. So, it has flyable behavior and quack behavior. Okay, it has a hazard relationship, and these flyable behavior has its you can see these are the interfaces. Okay, and it has got two implementations. One is fly duck behavior and no fly duck behavior. Okay, so if you see fly duck behavior, so ducks are flying, and if you see no fly duck behavior, then ducks are not flying. Okay, coming back to my duck class. So this is the swim method. Now this method is common to all the duck class, and so is the implementation. So that is why the implementation itself is written over here. So all methods can make use of swim functionality. So here it is for code reusability, it is easer for easer relationship for swim. Okay, and we are making use of inheritance, in short. That is what I'm trying to say. Now for display I've created it as an abstract method. Why an abstract method? Because we know that display method is going to be specific to each of the different subclasses. But display is a behavior of a duck which will have its respective implementation in each of its subclasses. It is not going to remain common. So which is why we have an abstract method called as display. So each of the different duck classes, that is mallard duck, rubber duck, whatever the ducks are there, they will have to implement this display method. Okay. Now fly behavior and quack behavior. Okay. Now this is also a common functionality. So fly behavior dot fly, quack behavior dot quack. Okay. Now fly behavior dot fly. So so this is the entire class, and you can see I have mallard duck. So mallard duck. Now this is my real duck. Now it should fly and it should quack as well. So I'm injecting the behaviors whenever the object creation of mallard duck happens. Okay. So I'm injecting in fly behavior, this fly duck behavior and quacking quack behavior. Okay. And in rubber duck, if you see, okay, so no fly duck behavior should be there. And in case of quack, it should be squeak quack. Okay. So quack, it is similar to flyable what we have implemented. Okay. Now, if I go to my client, you see I have created the object of mallard duck and I'm calling these operations of duck. Okay, then I created object of rubber duck and then I'm calling these operations. Now in this duck class, you'll also see this setter methods, set quack method and set fly behavior method. Why do we have a setter method? So that in runtime from client itself, I can also inject the respective behaviors. Now let's say in rubber duck, for say in future I want the flying behavior. Okay, what will I do? I can may simply call this set fly behavior and inject flying behavior. Okay, so to show you in the client, this is what I'm doing, right? So if you see the output is also here. So duck.fly first, ducks are flying. Hi, I am a duck that quacks. For quack behavior display, I am a mallard duck, and swim is common, so all ducks float, even decoys. Now I created rubber duck instance. Now flying I call, so ducks are not flying, you can see. And squeak, I mean quack if I call, so it is squeaking, and I'm a rubber duck, yellow in color, and all ducks for swim, all ducks can float. Now I set the flying behavior to it, right? So I said that the ducks which were not flying earlier by default, what the nature was, I'm changing it in the runtime that it should fly as well. So ducks are flying, you see, ducks can squeak, all ducks can float, and I am a rubber duck. Okay. So yeah, this was the entire implementation of it. I hope it was clear. You can try to implement this by yourself. Okay, it's a very nice and a very simple example to understand. Thank you so much. Bye bye.